Very excited to get started with our session today, the basics of passive solar home design. This is going to be our final session for 2022, so I'm so glad you could join us. Before we get started, we want to say a huge thanks to our top tier sponsor, Mitsubishi. They have ductless air source heat pumps that are super efficient as far as energy efficiency and easy to place and can be used strategically around the house to heat and cool as needed. They have ducted mini splits as well that can be placed and hidden behind walls so that you can get that air distribution that you need as well as fully ducted air source heat pump systems too. Take it from me, I'm in a cold weather climate here and I've been heating now for just about 2 years, all electrically using Mitsubishi heat pump ducted air source systems without backup heat as well. Never had a problem. Some of their systems have something like dry mode, which can be used to keep the homes, from stealing too much humidity, as a different option that you have with some of these devices. And also, they have contractors. They have diamond contractors that you can look up in your local area and get them to assist you in your project. What's really cool too is that for super energy efficient, low load homes, like I know you're all building when you go passive solar, you don't need much. So you can use some of their new products that just go very low in their heating and cooling needs to make sure you can get right sized equipment. So make sure you head over to MitsubishiComfort.com and check out everything that they have to offer. And on that note, if you're going heat pump, make sure to check out our second tier sponsor, Rheem. They've got the new ProTerra up to 400% energy efficiency. You can have your heat pump HVAC, you can have your heat pump water heater. Takes energy right out of the air. I swear it's there in the dead of winter. And the Inflation Reduction Act is giving out massive tax benefits and rebates starting next year on both of these products, so you can check that out. All right, so again, you're here, the basics of passive solar home design. Welcome. Before we get started, just a reminder, this session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. And today I'll be your moderator. My name is Brett Little, and I am the education manager here. As always, our courses are approved for multiple continuing education units, including AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. And it's approved under our certified green home designation, under energy, and under health. So, it is here where I'm at, winter, it's dreary, it's very cloudy out, the snow is coming. It can be a very sad time. And so I am super excited to at least talk about the idea of the sun. And I've seen projects, many of our members implementing passive solar design. I remember one of our members following their homeowner on Facebook sent a photo in the dead of February in Climate Zone 5 up here, where they were their house was overheating. They had their geothermal system turned off because they had to crack the windows open because it was just getting too hot. So we know that this works. And so I'm just really excited to have our member here, who's been a longtime supporter of GHI, Debbie Coleman, as well as Orla, who she'll introduce as well, here to talk about these strategies, how you can implement them, and how you can find help to get the work done. So Debbie, glad you could join us here on the other side of our webinars, and feel free to please take it away.
Okay, super. So thanks so much, Brett, for that introduction. And it is nice to be on this side for a change. I've been a member of GHI for a long time, and I get the majority of my continuing education from them. So it's nice to be given back. So I really appreciate that. And I really appreciate Orlo, who has been designing, building, rating passive solar homes for a very long time, and joining me. And I apologize that Christopher is not going to be able to be here today to join us, but I'll be sharing his slides. And thank all of you for taking time out of your day. I'm excited to be able to share knowledge on passive solar home design. So we're basically using the sun to warm and brighten homes. I know it's the warm part that gets a lot of the attention, but equally important to me personally is the brighten part. I actually like the outdoors better than I do the indoors. So if I can bring that outdoors into my home, I am a very happy person. So I mentioned myself, Christopher. I've known Christopher over 20 years. I've used his solar design tools for that long. He's an incredible individual. He is in the Pacific Northwest, so he understands the cloudy climates where everybody says, oh, solar doesn't work. And then we have Orlo from the middle of the country who has been, again, designing, building passive solar homes for a long time. And myself, I work with clients all over the US and Canada, so I'd like to think I have a well-rounded background in all the climate zones, but most of my clients are probably in zones 4 and 5. Okay, so the learning objectives, these are required for the AIA continuing education and other continuing education. I won't read through all these, but let me just say that. So basically what we're going to be talking about are the passive solar design components. Passive, things that have to be planned, designed for, and built in initially, versus the active components, which might be mechanical and or electrical. They may be prone to malfunction, whether it be a pump, a blower, a battery, whether they're inside the home or whether they're out with, in terms of PV panels or the electrical grid. And due to those failures, which may be man-made or natural. So that's the goal of the presentation. You can all see this now, right?
Yeah, there it is. Thank you. Yep.
Okay, that's what I wanted to emphasize. That's my goal of bringing the sun into the house. We've talked about the objectives. So the audience, Brett had sent this ahead of time. So, you know, it's not surprising that most of you are architects and designers. So that's very exciting and also a little bit nervous because I'm sure there's some of you out there that know as much as I do about this or more, and certainly more in other aspects. Okay, Brett, what about, can we go to this poll number 1 now?
So it looks like we've got a really strong mix of single family renovation experts here. So wonder what we can do with passive solar there. I know it can be a little limited, but. And new construction looks pretty high as well if you scroll down. So I don't know if you can see that, Debbie, or not, but.
Yeah, okay. All right, and then this poll. I would love to know what climate zone you're in. So go ahead, Brett.
And that should be launched.
Okay, 5. That definitely is the highest, as I probably would have expected. That's where you are, Brett, and that's certainly one of the climate zones that can really benefit from passive solar. Okay, so I'm going to move on fairly quickly now. It might seem too quickly, but I really want to give Orlo time to talk and to be able to pause for any critical questions that come in. So like I said, we're using the sun to warm and brighten homes. We're designing for the sun's natural light and the heat. And it's really kind of an art and a science, especially with climate change. It's hard to predict whether in December it's going to be freezing cold or 70 degrees in some locations. The course outline. First, we're going to go through some simple how-to and inspiration, introduction. Then we're going to get into some design basics. That's going to be probably the meat of the first part. Then touch on 2 different design tools. And then we'll cover some examples. And the examples will be starting with Orlo and his passive solar subdivision. We'll have some examples of passive solar homes that meet passive house standards, that are net zero energy, and some other energy professional examples. And then we'll have some resources. So if you feel like we're moving too quickly and you want to know where to go after this, there'll be a resource section. So every home is a solar home. We can either use the sun's light and solar energy, or we can let it go to waste. And this is not anything new. I mean, historically, the Native American Indians have been working with passive solar. The Pueblo Indians, known as the Anasazi, built hundreds of structures into south-facing cliffs in the US. Ancient Greece, there's a prime example of a city that's backed up to the mountains with all the homes facing south to capture the winter sun. And in the US, George Keck was the first architect to pioneer passive solar house design. In the 1930s, he was playing around with glass and mass. And yes, some of those really overheated, but he went on to design and have the homes built in order to be able to explore just the options. So Keck and Sloan kind of kicked it off in the United States, and they influenced Frank Lloyd Wright when he started to incorporate passive solar design in the 40s. So passive solar is heating by the sun. There's no active or moving parts are needed, although it's undeniable that the active parts can increase the comfort zone, fans, pumps, heaters. So in the United States, heating and air conditioning is roughly 50% of a home's energy use. And here I've mentioned the ranges of cooling and heating in the different regions, but overall it's roughly 50%. So if we can reduce the space heating and cooling by 50%, then we've just cut off a huge chunk of our energy consumption. So the overall goal, I think, is passive survivability. You don't hear this as much as you used to, but this was attributed to building science expert Alex Wilson, who defined it as maintaining livable conditions in the event of extended loss of power or interruptions in heating fuel. So they're really resilient design strategies, and a lot of them are climate specific, but they can include the passive solar heating, passive cooling, which they're really, a lot of times the principles work both ways. Resilient strategies, moving a little bit into the active side, can be PV with battery backup. But even with PV, in my opinion, a building should be livable for at least a few weeks without connected utilities. Again, looking at the active versus the passive. Active, here's an example, easy to see, applied to a building later. In this case, it's on the roof. A lot of times it might be a ground-mounted system. The passive features that must be designed in are going to have to do with the orientation, the windows, and the overhangs. So passive solar, along with passive cooling, increased insulation, decreased air leakage, and smaller HVAC systems, they can reduce the number of PV panels that are required to power a home, sometimes by as much as a half. So we're looking at the south roof of a house. When you see a lot of PV panels there, and you know the sun hits that because it has to create electricity. But what is often overlooked is that the south wall receives almost as much energy as the sun's energy, as the roof does. And in the wintertime, the south wall is actually going to get more sun's energy than the roof. But roughly they're the same. And the ranges that I have are sort of from maybe the cloudier parts of the US to the sunnier parts, but relatively the amounts are equal. So when we add the active solar, we can take it to another level. The house can then be 100% powered by the sun. So all the electrical appliances that we use in the house can use that electricity. And it can go even further. The solar that's generated can also be used to power electric cars. And I think we're hearing a lot about that, a lot more lately. But the solar energy can also heat water. The panels typically are on the roof. They don't have to be. It's the same water we use for everything else in the house. Here's a picture of a passive solar hot water heater that I had on a house. I love that. Our neighbors were without power, and us without the grid for two weeks after a hurricane. But we had hot water because it didn't have any moving parts. Solar energy can cook food. You can make a solar cooker from a pizza box. You can buy some through Amazon and eBay, or you can build one yourself I like this one up here, into the south wall of a home. And the sun can also purify drinking water. This simple little system here, about 2 feet by 3 feet, might be able to create on average, distill a gallon of water a day. So that might be enough for a family to have for drinking water in the event your drinking water supply was contaminated. And one of the simplest, one of my favorites is that it can dry clothes, need to run the dryer less. And one of my favorite design strategies, if the client is up for it, is to have a clothesline outside of the laundry room to make it easy to put those clothes out. And if there's a porch or a carport there, it's even better, because then if it starts to rain, you don't have to run, take them down. So there are some passive solar house design prerequisites. A lot of people will say, oh, I had, especially in renovation, oh, I have this home, I want to add passive solar. Well, my answer is usually, let's tighten the shell first. Let's get that energy consumption as low as possible, and then we'll add passive solar. So you want the well-insulated roof, walls, floors, best windows you can buy. You want the home to be tight. You don't want the air leaking out through all the cracks. And you want the system to be right-sized. And unfortunately, it does well. I should say, fortunately, the system will be right-sized to the highest load, which would be a day when you might not have sun. So the HERS rating that seems to work well is that if you can get a HERS rating of 40 to 50 pre-PV, that seems to be a good goal. Thicker insulation, that's kind of a given. It keeps in more heat in winter, it keeps out more heat in summer. And typically I like to recommend a little beyond code, but depending on the client, the budget, and the priorities, it might not be that much beyond code. You want the home to be sealed tight. Again, that keeps out the cold winter air and the hot summer air. But what comes with it, especially in hot, humid climates, is the humidity. And of course, there's the dust. And what I like to emphasize too is that it also helps with pest control if the house is sealed tight. Right-sized, that's really essential to comfort. People will say, well, will my passive solar home be comfortable? Well, if the heating and cooling systems are right-sized, yes, they should be. And Brett talked about Mitsubishi being one of the main sponsors. Yeah, we specify mini splits in a lot of our projects.
Debbie, on the right sizing aspect of it, how often do the HVAC take into account passive solar when sizing, or is that a conversation you have? Or, and if you're getting to that, feel free to stop me. So
no, that is a great point, and I will address it briefly. If you have a mechanical designer which is familiar with passive solar, then to me, that's the best scenario, because unfortunately the software, from what I gather, WrightSoft, for instance, might be the most commonly used one. I had a conversation with Bill Wright at one of the conferences, and correct me if I'm wrong, Bill, and it's not the same, but admitted that part of the software could use a little bit of upgrading, improvement. But if the heating and air designer is aware that passive solar is going to be used, they might push the limits of the design a little bit further, because I believe there might be overcompensated for in the software. The consultants that we've used with HVAC have said that routinely the software would overestimate the heating needs of a home.
Thank you.
And then, of course, fresh air. That's kind of a given when you build a tight home. Even though I'm completely okay if somebody can achieve a house of 0.6 at the passive house standards, I found that typically getting to 1.5 is a pretty good number to strive for. And Allison Bale in his House Needs to Breathe book covers a lot of these mechanical components. Just another, I don't know if you'd call it a prerequisite, but something that I like to stress people aim for as small as possible. People say, what's the most energy efficient of your home designs? I'll say, well, the smallest one. So the smaller you can make the home, the less energy it's going to use overall, whether that energy is from the sun or electricity, or do I say the G word, gas? Anyway, to keep the building compact. Compact as much as possible, slightly elongated is going to have the most amount of volume for the least amount of wall surfaces through which to lose and gain heat. Compact footprint, one of my favorite strategies if the client's land faces south, is to have a daylight basement. Instead of spreading out with your design, you're compacting it in. Put those 2 bedrooms down on the sunny south side instead of building up a second floor. Nestle as much as you can up against the soil, which compared to outside temperatures is relatively warm when you're looking at 40 to 76 degrees throughout the US below grade versus below 0 outside sometimes. It can feel pretty cozy. Okay, do we have any questions on the prerequisites before I get into the basic design concepts? Okay, well, let me keep going. And again, I'm going to move rather quickly. So basically, there's 4 basic design concepts. Orientation, you'll want the long side to be toward the south. Again, we're talking northern hemisphere. Windows to maximize those on the south side. Overhangs to shade those windows in summer. And thermal mass to store possible excess heat if the south glass is greater than 7% of the floor area. So, and all of these things really only have to be done once in the planning stage, which is really the same as the design stage. And then you'll reap the benefits for years to come. True north and magnetic declination. So compasses, you go out to the site and you say, oh, I want to see where true south is. Well, you really need to pay attention to the declination, because in the United States, from the northwest to the northeast, the variation, if 0 is in the middle of the country, it's going to be 18 degrees off on one side and another 18 degrees off on the other side. So to be aware of where true north and therefore true south is very important. This website is one I use all the time. So the sun's seasonal movement, it varies from summer to winter. I think most people realize that, but it's easy to forget, but it's a basic passive solar design concept. In summer, the sun is going to be almost overhead at noon. It's going to be high in the sky. It might be close to 90 degrees in the far southern part of the United States. And in the summer, the sun is going to rise in the northeast. It's going to spend a lot of time on the east side of the home. As it moves around the south, it's going to be high. And as it sets, it will set in the northwest. So most of the sun is going to strike the roof and the east and west walls, and not so much will hit the south wall. In winter, the sun is going to be much lower above the horizon, about 46 degrees less, based on the tilt of the earth from 23 degrees one way to 23 the other. And in winter, the sun rises in the southeast and it sets in the southwest. So most of the sun, when the sun is lower, is going to hit the south wall. So very little is going to hit the east and west. So you want to start observing the shade patterns. East and west is great for shade, but typically you don't want tall, dense trees to the south. And this time of year is the perfect time to go out to the site and have a look. And remember, if it's a 2-story home, it might seem like that wall might be in shade, but once the house is much taller, there might be plenty of sun higher. Solar Pathfinder, this is a really cool tool. It's really simple, and you can use this on any day of the year, even on cloudy days. You take it to your site and you can trace the shade pattern. I'd like to spend a lot more time on this, but just trust me, it's very cool. And typically, whoever might be your active solar consultant would also be the person that would have this tool, who's designing the PV system, so they could come out and help you assess for the passive solar aspects. Building shapes, they definitely affect the amount of south glass possible. Certain shapes, there's just no south wall in order to put windows on. So you want to pay attention to that early in the process. I already mentioned that the south wall receives more direct sun in winter. So on typical, like say, if the decent amount of sun is between 9 a.m. and 3 p.m., that gives you 6 hours of sun on that south wall. The east sun might only get 3 hours, and that's going to be coming in at an angle. And then the west, again in winter, might only get 3. So you can't really depend upon it. And so it's only the south windows that are going to have net heat gain. The east and west might have more heat being lost back out than is gained during the day. So some rules of thumb of glass area. And again, this is compared to the floor area of a house. West glass, keep it to 2% max due to the possibility of overheating. Of course, you could go higher if you had porches there. North glass, the recommendations which come from these guidelines I'll reference later, mention 4. I like to go less if possible, especially in cold climates. East glass is also at 4. Again, a lot of times the east light is really nice, and that heat is not as detrimental to the house as the late afternoon. On the south, I would love it if every house could get 4. Even if you can't get 4, get 3. 7% is a really good target that's fairly easy to achieve. And so up into 7%, we call that sun tempered. Up to 10% is also possible. But above 10, you start to get into some overheating issues, even with a lot of thermal mass. And of course, there's tons of exceptions based on the homeowner's comfort levels, time of day, but these are some good rules of thumb. So just focusing on the south glass again, 4 to 7 is sun tempering, 7% requires no additional thermal mass, 7 to 10, some extra thermal mass, and 8% seems to be my new favorite. 8% is easy to get without structural concerns, you can have just a little bit of thermal mass without an excessive amount. And this is just an example on this 1,200 square foot house. How many windows would that be? So this is 7% here. The south glass, you'll want that glass in the south windows to have a high solar heat gain coefficient. And typically it might be 0.68, just for the glass. But the window sticker, the one that arrives on the job site, might show a much lower number, might just show 0.51. Well, that's because the National Fenestration Rating Council, they rate the glass and the frames together. So if you have spec'd a certain type of glass and you see this sticker on the job site, know that the glass could still be as you specified. All glass, I like to specify as high of R value as you can afford. Triple pane if your budget allows. In any case, insulated curtains inside can add an additional R4 to R10 to the windows. So if you're a client or homeowner that doesn't mind pulling the shades, is conscious of the energy loss, then when you don't have direct sun coming in, pull those shades, slow the heat loss down. Some examples of overhangs. Here on the left, you see it's not quite winter, but you see this shade line up here at the top of the windows. In summer, the entire south wall would be in shade. Here's another example from Allison Bale's book. He has an example. This was a home he lived in. Full winter sun, full summer shade. I also like to use SketchUp for overhang design, mainly because it has the geolocation feature, and you can turn that on and you can slide the scale to see, is it noon? Is it 3 o'clock? Is it 10 o'clock in the morning? How's my overhang gonna look? So in this particular example, again, you can see summer, here it is full shade. Winter, here it is, full sun. This is just an example at 40 degrees north. Porches, again, I think I mentioned those. They're great for east and west. So if the front of the house faces east or west and you want a front porch, then, go ahead and put a few windows there to make it more attractive. On the west backside, add some tall trees to shade that wall. Briefly, I'm not going to spend a lot of time on thermal mass because this just has so many implications, but if you have more than 7% of the floor area, add some thermal mass. My favorite is a slab on grade because it's inherent, it's nothing extra. It's already part of the construction cost, part of the design. And the rule is for every square foot of glass, you need 5.5 sunlit floor area to temper that throughout the day. If it's a wall that's in the south facing room, you might need 8 square feet for every square feet of glass. And those materials can be concrete, brick, stone, tile. And just one other thing to mention is that more than 4 inches is not recommended because more than 4 inches sometimes will have too slow of a lag to reduce to let the heat back out. One of my favorite cooling strategies is to rotate the house 10 degrees with the south wall facing 10 degrees toward the east. And when you do that, you'll see by using some of these tools that the south wall will be in full shade earlier, full shade in summer than it would if it was facing due south. If you start orienting it to the west, that's when it really becomes challenging. But these overhang tools will help you in that aspect.
Debbie, on the thermal mass part, I'm curious. You had said slab on grade was your favorite, and that's a normal right? That's a normal. Obviously, trying to convince people not to build basements there's some challenges there, opportunities, but you're not saying any type of special slab on grade or flooring. Just a slab on grade system is your favorite.
Absolutely, yes.
Yeah,
interesting. And it's probably between that and the cost reduction, that seems to be what people really like.
Plus, if anyone's heard of the Michigan basement syndrome, you don't want that. It's not fun. I've had that one before.
Yeah. So thanks for asking that, Brett.
Yeah.
Passive cooling. Again, we've talked about balancing windows. Well, if those windows can also be operable, windows on opposite sides of a room will help with the airflow. They also help with balanced light. If you have light coming from at least 2 different directions in a room, you're going to have less glare. If those operable windows are placed high and low, that's going to help with the stack effect, which increases cooling even further, which is a very popular strategy, especially in dry climates or even in humid climates for clients who might have a wider comfort range and not use air conditioning.
Yeah, so there was another question for you about the solar chimneys and the passive solar chimneys. Do you utilize that at all in that context?
Well, the term passive solar chimney, I usually will ask people, what do you mean by that? Because there's a lot of different so-called passive solar chimneys out there. I have a home I recently completed that's actually 4 stories, and I still don't call that a passive solar chimney, but it has a high stack effect. But that was designed that way because the client needed a very tiny footprint, and to get all their spaces in, we had to go vertically. So I do have something that I integrate into a lot of the homes called a daylight cooling chimney, and that might be something that's very simple. It fits between 2 trusses, 24-inch on center, and it would allow both light to come in through the top and an operable window, motorized operable window. That's why I'm kind of hesitant to talk about it in the passive, could then allow the heat to escape during the passive cooling system.
So it's using passive features, but it has an active component. Is that fair?
Right, those windows. Yeah. I mean, I have had clients that have had the long pole, but they've said that's really kind of a pain to do. Sometimes I've designed I have one design where you go up on a little catwalk so you can access the hand cranks on the clear story windows. I love doing things like that when it's possible to turn it into a passive feature.
Yeah. Thank you.
Okay. Now we're kind of getting into the active. I'd like to say simple active, if that's a term that I can use. Some simple fans that might distribute air from high to low, from the high ceiling on the highest floor, a small inline fan. It might just be, 100 CFM, and it might just be a 4 to 6 inch duct, and draw that down to the basement. If it's near a heat pump hot water heater, I'd like to think it's also that any extra heat is being absorbed there. So really, passive solar, it's really a part of the holistic design process that's done before construction. So I'm just kind of going into the summary here. I've talked about just passive solar, but you're juggling that at the same time you start with the homeowner wish list, which may or may not include passive solar. I have snuck in passive solar plenty, especially in past days. Nope, I don't want that. But, I could still meet everything else they need and sneak some in and know their house was going to be lower energy and better performing. But enough of that. House siding, you're dealing with the climate and the temperatures and the humidity, the floor plan functions that the client wants, construction materials, what's available in your area, what does the builder prefer to use, structural issues, too much glass can be problematic, too large of big open spans can be problematic. Exterior design styles, does the client want something very traditional and comforting, or do they like, clean line angles, mechanical systems? Sometimes those come with a heavy preference. Construction cost, that maybe that should be up at the top, because people will say, well, what's the best passive solar home? Well, the best affordable home that you can, the smallest, best performing home that you can afford, etc., on homeowner preferences. So the designs are climate specific and they're homeowner specific. Again, getting into maybe too much detail here, but just to point out that they're important. What latitude are you at? What's your elevation? Are you in the mountains? Are you in the plains? Where's your wind speed and direction? That might affect where we place the windows. A biggie is are the occupants, are they cold natured or are they hot natured? You might design it completely different depending on who is going to be using it. Times of use of the spaces, seasonable occupancy patterns. Vacation homes are a completely different challenge. Although I can say that clients that we hear of that are using it that way, are finding the daylight basement areas, they stay around 55 degrees. So I think that's nice. They will worry about the pipes freezing, but if you have some passive solar coming in, it might be a little too cold for you, but it's not going to be too cold for the house. Ask the client their preferred thermostat settings. And then just how active are these passive solar occupants? Are they willing to operate windows and pull down insulated curtains? So there's no such thing as an energy efficient home, just energy efficient occupants. Okay, and I'm realizing now, I think I might be going a little over on my scheduled time. So I'm going to breeze through, start with the passive design tool. So is this a good time, Brett, to ask, are there any basic design questions?
Oh, we've been getting through a lot of the questions, so I appreciate you answering those. And there's a lot more coming in, but we'll keep hanging out and asking. So
okay, all right, sounds good. Okay, passive solar design tools. So Christopher has a lot of different tools. I really wish he was here to talk about it, but we have a link in the resource where you can access the hour-long presentation he did for Green Home Institute on using his tools. But he asked me to talk about these two today, the overhang design and the quantifying passive solar tool. So this is where I'm going to look at my little cheat sheet and mention that. So Sustainable by Design offers several passive solar design tools for free. Technically, they're shareware, funded in part by your voluntary user donations, but the tools have grown and evolved over time based on user feedback. He's a very accessible open kind of person. And in 2003, he has a new website coming up that's going to be more mobile device friendly and will serve as a foundation for even newer and more integrated tools. Again, just an overview of when you go to his website, some of the tools that you see. The overhang analysis overview, it starts out up here with a graphic representation of the window that you're going to analyze. And then through the different functions at the bottom, as you change these sliding scales, you'll see the shade pattern above the window change. So these are the different choices that you have. You have the latitude, the date, the time, the direction that the window faces, the window width, the window height, the overhang width, the overhang depth above the window, the horizontal offset. And then the chart, you can choose how the information is displayed. So in this particular case, what you're seeing is this is the amount of shade that that window is seeing. So if you go to the dead center, you see 66% in shade at June noon on an afternoon. I would say that's not good enough. You would want that, for instance, to be at 100% for, I think, I don't know of any climate that you do not want 100% shade on the summer solstice. So looking at the window heat gain, how much heat comes through this window. So this tool, if you want to play around with quantifying that and then plug that into maybe some of your own Excel spreadsheets or your own tools, a lot of people have their own simple heat loss and heat gain tools. You pick the city, and then if you pick the city, there's usually 3 or 4 for each state. It will automatically fill in this other information for you, but you can also customize it. But for instance, so you pick the city, it's going to tell you the latitude, it's going to tell you the percent of sunshine that that area is going to have based on climate data. The surface, especially if there's snow, wow, you can have a lot of ground reflectance assisting your passive solar gain. And then the custom window information. This is where you can plug in your solar heat gain coefficient and the orientation of the window. So after you plug all that in, well, I guess I just covered all those. Oh, but then on the output format, you can choose, well, I think the default is kilowatt hours per square meter, but there's also a choice of BTUs per square foot. So here's an example of the output. So this is going to give you your units, and this is going to have it by month and that time of the day. And then this will total the amount of heat that you can, the heat gain that you can have on those various, for each month total. This is my favorite tool of his. It's called the overhang annual analysis, and it shows the percent of sun. And this is what I like to use to help visualize. I'll start with the wall detail that I have. And so up here, you'll put your overhang depth in, and I'll typically go ahead and include in the gutter in that. The distance from the bottom of the overhang to the top of the window, and that will be determined from this part of the detail. This is showing a jacked up truss, so that can make a huge difference in the height above the window. So that detail of roof to wall framing really needs to be considered. Then the window height, and I like to see the direct sun and hit calculate, and you can look, you see here we have in May through July, it's all in shade. Here we have in winter, mostly that's in sun. And here's the link to the video where you can go and see an hour's worth of Christopher talking about his tools. Another way to quantify passive solar design. This is something I learned from Mark Rosenbaum. He teaches net zero energy classes. He's in the Northeast. He's just an incredible engineer, excellent instructor. And the class that he teaches, which he's still offering through Heat Spring, the one that I took was, it went over several weeks. I want to say it might have been 6 to 8 weeks. We had homework assignments. A lot of it was online, go as your own pace, but it was also interactive and turning in your assignments. But he introduced PV watts and how you could use that. I guess this might be an audience question. How many people use PV watts with active solar design already? So if you're used to using it with active solar, then using it for passive solar, should be relatively straightforward. So when you go to the PV Watts website, it's really very simple. Up here, you enter your zip code. Okay, I'm also presenting Mark's slides, so I'm sorry, I'm getting a little bit ahead. Okay, so he was just emphasizing that you can it shows how much electricity can be generated, but it can also be used to calculate the average monthly solar gain. And basically, you're setting the tilt to 90 degrees. So this tool is basically used for the PV panels on the roof, which may be at, anywhere from 25 to 45 degrees. But when you're putting the windows in, you'll do the tilt at 90 because you're looking at the amount of energy that comes through a vertical window. So you enter your zip code, you hit go. Then you hit, it'll come up where the resource is coming from. Occasionally there's a different choice, but usually I just click OK, whatever the default one is. And then these two boxes in red are really the only two that you have to change. You want to change that tilt to 90, assuming your windows are vertical. And then the azimuth, that would be the direction off of due south. So if it's facing due south, it would be 180. If it's facing 10 degrees east of south, it would be 170. And Mark's example here, he has 167. And then it will calculate for you the amount of kilowatt hours per square meter per day for your particular climate. And it's really surprising how little that varies throughout the US. And then there's an export function, for lack of a better word. I think Mark mentions download. You can download those results in an Excel format, and you can put it into an Excel sheet that you're working on and manipulate. In his example, he pasted the PV watts output into a simple spreadsheet, and he converted it then to BTUs per square foot per day, and then another conversion to get it into per month, because that's a more commonly used home energy data format. And here's a graph of that data. So you can see that the highest amounts are in the winter time. Okay, so note that this data is the amount that reaches the exterior of the glazing. So for passive solar, we want to talk about the amount that gets into the building. So then there's another layer of factors that would need to be applied. And sometimes, I might just have an extra column where I might enter that factor in a spreadsheet. The solar heat gain coefficient of the glass, any shading. If you know that it's not going to get any sun in June, you could plug in, 100% shading there. And then you only would be using the indirect heat gain through the window. And then the soiling on the window. So he uses a factor of 0.85 reduction factor for that. So here's his example. I know it's a lot of words, but in summary, his January load, he is showing 1.4 million BTUs is the amount of energy that he's getting through his 100 square feet of glass. The gross heat loss of his house is 5.3 million. So if you divide that out, that means the solar gain on his house is providing 27% of the heating load. And this is in the Northeast in a climate zone 5 for his particular house. He had modeled that for his heating load to use 308 kilowatt hours. And over the past 7 years, his house has actually averaged 254. So that's fairly close. Here's a poster that I created that I did for the American Solar Energy Society conference one year, where I took all of this information and put it into a poster. And if anybody would like a copy of this poster, email me after, I'll be glad to share it with you. But here you can see where I added my column in for the shading. Okay, so I'm delighted to start turning this over to Orlo. Do you want to stop and have any questions on the tools, Brett?
There were a couple of questions on the tools. Thank you for asking. Let's see up here, going back to, well, there was a question, in what latitude is that green shading chart? Maybe you mentioned that, but can you just reiterate that?
That might, I can't remember if his example was, it might have been 45 or 40. But okay. I definitely encourage you to go there and play around with it, because you'd be surprised at how drastically that's going to change based on the latitude.
Okay. And then was there, I guess people were asking for links, but I'm pretty sure those links that you were referencing are all at his website and then on PV Watts. Were there any other additional links you were referencing?
No, and they should all be in the resources, or if not, watch this again, and we've pasted in the links of where you get to all this.
Yeah. Okay.
So,
yeah.
And I am about 2 minutes over where I hope to be, to not get into Orlo's presentation. So I have a brief little intro of Orlo before I'm going to, let him take it over, because he's an incredible person, and he might be really modest talking about some things that he has done. But so his part here was mainly talking about his subdivisions, but for I don't even want to know how long, he and his designer have been designing, building, testing, rating, and developing, passive solar homes for a very long time. And he has written a book, Holistically Green Homes, incredibly well-rounded. But Suzanne does the design part of his homes and does an excellent job with the passive solar part. Orlo specifically, you can see all of this, but he's jumped through all the hoops. Builder, he was a rater, built a passive solar home in Canada. He started his company in 78. They now have 4 divisions. He's built a LEED platinum rated building. He's gotten 18 awards, and he's a fellow of the American Solar Energy Society. And this last year, he received the Solar Architecture and Design Award for ACES. And last but not least, he's the author of Holistically Green Homes. So I really appreciate it, Orlo, that you are helping with this presentation. So I will turn it over to him and stop sharing my screen. Thanks, everybody, for listening to me.
First of all, I want to express appreciation and thanks to Debbie, who has put this all together, and her knowledge and her organization's appreciated. I'd also like to say thank you to the Green Home Institute and Brett Little in sponsoring this free webinar, which the world needs. And So thank you very much. I would like to start out with something kind of unique. We have a marketing lady who is very creative, and she has programmed her phone and her drone to follow her wherever she goes, kind of like a puppy dog or whatever. And so she programmed it, and we have this video, which I want to start out with, called a walking tour of South Sun Estates. So sit back for 4 minutes and see South Sun Estates subdivision, which is actually a summary in different ways of whatever we've been talking about today for the past hour. So I think you'll see it's a different approach to it. Many of the homes in are net zero in the subdivision. All of them are highly efficient. Not only are these homes in our subdivision, but we've done maybe 1,000 passage solar net zero or net zero ready homes, and some with what we call net zero plus, in that it's not only net zero for the house, but they have enough extra power to charge their electric cars or car with sunshine, and maybe their shop tools and their yard tools with sunshine. So it really is a trend, and I see it moving progressively now, particularly with some of the things that have happened both technically and politically in the recent past. Subdivision is 38 acres. There are 22 houses now in it. We have 7 empty lots. And so sit back and watch.
Orlo, while they're watching, where would you mind sharing where this community is?
Brent, I don't know if he heard you, but it's in
What was that?
northwest Arkansas.
Yes, in Arkansas.
Okay, thank you.
We've done homes in 18 states now, though. Whoops. Some people have questions about how you can put together a subdivision and maintain the quality control and get the people to participate. It's a holistic, it's a wonderful group of people. They all care in a different way than most of society does about each other and their neighbors. But we have a staff that designs a home. Each home is designed separately for the customer and their site. The homes include as many passive solar and energy efficient features as possible. The plans for every home must be pre-construction HERS rated by a certified HERS rater who also does the final one. It's really not a over use of his time and money and so forth, because he picks up and does the final. Various independent builders do the contracting. We've done homes, like I said before, in 18 states. We've worked with the builders there with a three-way contract, very unique, prepared for our specific needs, and it works. The best thing of all is that the customers are happy and the houses turn out to be incredibly efficient. People also say, particularly builders and developers say, oh, we couldn't do that. That's too expensive. We just can't run even one home energy rating on a home, much less three, in effect, a midterm and a final, because of money. Well, I argue, and I say strongly disagree with those builders in that the money is there, the savings are there, the value is there. Our appraisals are higher here in Northwest Arkansas, home of Walmart and all the other big things that are happening, including the Arkansas Razorbacks, of course. But anyway, we have the best appraisals and satisfied customers. Almost 100% over 1,000 homes. An incredible record for building. The second thing that we do is we run this blower door test after the preliminaries. And at that time, we slow the fan down so it doesn't blow the foam out of the places where we patch the leaks. We go up into the rafters, we find where that foam is leaking. If anybody thinks their houses are tight, just put a blower door test on it and take a smoke pin around, and you'll find leaks everywhere. We use an open cell underneath what I'm going to show you in a minute, the ice house roof. That allows us to fix with foam or caulk the leaks without it sucking the foam and caulk back out of the hole. So at the end, we have usually a very, very tight house, much lower than most people are used to. Then after the house is completed and the occupants, we have a third party doing the HERS rating. We found out the hard way that if you don't do the midterm, that if you don't get the leaks out and you've promised customers, we've had customers, one set particularly that drove 300 miles multiple times because they wanted a highly efficient house. Well, we did their house and guess what? It leaked like a sieve. And this is probably 25 years ago. And it leaked like a sieve, and by that time, the wallpaper, the painting, the flooring, everything was in, and it is almost impossible to fix all these leaks if you don't fix them at the midterm. So if you want a good final exam, you better have a good midterm. So that's what we do and how we do it.
That is an awesome saying. Thank you for that.
Passive solar, highly efficient, economical. In chapter 10 of my book, I talk about what is a ice house roof. This is a passive feature, no pumps or motors or anything, and it's highly economical. It is appropriate to add that this technique does not work on flat roofs or stick framed roofs. It has to be a truss roof to be practical. The next slide shows the fact that it's old technology that we brought forward. If you look at the little down to the left, you see a block of ice moving up a conveyor into the ice house. You see the little cap on the ridge, the vents. There's sawdust or wood shavings or hay or whatever they had in 1850, because this was prior to electrification of the houses in the countryside. So they had to somehow keep their milk and cheese and bread and whatever else they wanted to keep cool for a little bit longer. Things that would spoil, not be edible. And so they had ice houses that stored the ice for their ice boxes. Old technology brought forward. I'm going to show you the next slide now. It's the page out of my book, chapter 10, the introduction. You see the diagram there. You also see in between the trusses with raised heel trusses, mind you, that allow air to move over the top up through and out the ridge vent. I'm going to show you another more specific diagram here, a little close up there. There pulls in underneath the eaves because hot air rises and the sun's heating that hot air or the air underneath the roofing. It keeps moving, and the hotter the day, the faster it moves. Now, unlike 1850 and cutting ice off lakes for ice boxes, we have foam insulation, which we put underneath the ice house sheathing. It can be R30, it can be R50 or 49, whatever you want. But one thing that we found out that Oak Ridge Laboratories confirmed is that spray foam properly installed and air sealed is 30 to 50% more efficient in an R factor number. The other thing that happens is that cellulose and fiberglass and other insulations absorb a certain amount of water, but yet the testing for R factor is done bone dry. Seems paradoxical to what the results should be, but that is the way it is. Here's what it looks like from the outside. Notice the hips, that we also have the ridge down the hips that allows it to ventilate that part of the roof also. Here's what it looks like from the inside, completely foamed, air sealed, tested, blower door tested. And then we go to the next slide and you see some of the economics related to it. The Oak Ridge Laboratory said that the airflow underneath the roof, properly vented, is 46% more efficient on a summer day's cooling. But based on studies and comparisons that we've done, we've found with the foam insulation and the sealed attic that we're about 64% more energy efficient in the summer. So maybe ice house would allow us to shut down some coal generation plants and make a further contribution to climate change. Another little side, which was touched by Debbie, was many of our houses now, we're putting in mini splits or just a small amount of ductwork with mini splits. Even 3,000 and 4,000 square foot houses, we have 1, 2, and maybe 3 mini splits. That's true of my own house. I have a 3,000 square foot house. We have 2 mini splits, and amazingly, our bills, partly because of direct current as opposed to AC current, have dropped dramatically. I'm going to close here with kind of a satire on what I call production housing. We have production housing here. We're in a boom area with Walmart and everything and the university. And we, my son, and that's who's in the picture, David, and I have a hobby of walking through subdivisions, usually when nobody's there, and just seeing how these things are built. Even in Iowa and Minnesota, where we have relatives, the houses are built custom track trash down the street. The house follows the curb, should follow the sun, but it follows the curb because that's the way builders want to do it. And that's the way Grandpa did it, because Grandpa taught Daddy and Daddy taught son. Ain't no other way to do it. So sit back. This one's only 2 minutes.
If you went to your mechanic and you said, Mr. Mechanic, my car's getting really bad gas mileage and I don't know why. And he says, well, let me come out and look at your car. And he walks out in the parking lot. He goes, well, I know what's wrong with your car. You have square wheels. Your car isn't going very well because it's not very efficient. It has square wheels. And you say, well, what would I do to fix that? Well, we're going to put round wheels on your car instead of square wheels. That would take your car from being very inefficient to very efficient immediately. It's low-hanging fruit. And so we talk to our customers all the time that too many homes in America are built with square wheels. They're improperly structured. And when I say improperly structured, they're structured or built or framed in such a way that the insulator cannot effectively insulate and air seal. When we go through our process of design and build, we design the structure so that it's properly framed, not only for the sake of the strength of the house, the insulation, indoor air quality, there's a variety of things that flow out of that. And if it's properly structured and framed, properly insulated, then we can go to your heating and air contractor and say, we need to put a much smaller heating and air system, or maybe we only put one heating and air system instead of 3. And then the customer saves on the cost of the original equipment installation. They save on the maintenance of those other systems for years, and they save the energy. And we want to find the low-hanging fruit. We want to get rid of the square wheels so that when our customer moves into their house, they say, I have a house that just by its design and structure and all these little details, it simply just uses less energy.
Thank you. And thank you for the opportunity to speak with, it looks like about 160 people. It's a real privilege.
Yeah, thank you so much, Orlo. Debbie, did you have more you wanted to add before we get into the Q&A?
I do have more slides of some examples. So
yeah, why don't you do that?
Go through that briefly. I can go ahead and put my screen back up if that's okay. Orlo, you'll have to stop yours.
Okay. I think I did go over a bit, so I apologize for that.
Well, that's probably because I went over a bit, but anyway, thank you very much for
My outfit.
assisting. Okay, now I'll try back to mine. Okay, everybody see my screen up here now that starts with the American Solar Energy Society, the national tour. That's been going on for over 25 years, and typically it's in October. This next year, it's going to be I think it's October 6th through 8th, sometime around there. And they have all kind of solar projects, not just passive solar homes, but active solar and communities, and just a lot of cool information. So I encourage everybody to go there for lots more solar examples and to join the American Solar Energy Society. I hope I can mention that since they're a nonprofit during part of this presentation. So just quickly, I just wanted to throw out some other examples. We get a lot of questions. How does this compare to the passive house? Are you talking about two different things? We're talking about integrating the same factors. So here's an example that I like. 2,000 square foot home where his window heat gain provides 60% of the winter heating needs. And I believe this is in climate zone 6, and they just need a 12,000 BTU mini split. Here's an example of a colleague of mine, Keith Sharp, and his home simulated performance, 100% passive solar heating, 100% nighttime ventilation cooling, although it is in climate zone 6, so that's not as much of a challenge. But anyway, the heating part is incredible. When you look at his actual performance after having lived there for 2 years is just under 100% passive solar. He's used 30 pounds of wood per year. And here's his peak envelope loss. And on his house, the solar apertures is just under 7%. Here's a home that's in the Pacific Northwest, I believe, Oak Harbor, Washington. And he was one of the winners this year of the Net Zero Energy Ready Home competition. Over 2,000 square feet, climate zone 4C, pre-HERS of around 40. And if he didn't have the PV, his annual energy cost would be under $1,000 a month. With PV, he's getting money back. Here's another architect that I like. He's also very involved with the American Solar Energy Society, Alan Spector, the Helios house. It has just this wonderful feel inside, and his passive solar provides 65%. He's in the Northeast. Some architect designer friends of mine in New Mexico who are doing some really cool things with Adobe. On the left, these are some new homes. And then on the right, here's a passive solar addition, this 2-story addition here in the back, Andrew built onto his home. So this is south facing, but the existing home that he purchased and renovated actually had the long side facing east. So I thought he did a really cool addition back here. And then I'm sure everyone has heard of the self-sufficient earthship homes by Michael Reynolds. There's just lots of really cool examples of earthships. So I find them very inspiring, and especially this one that's near Antarctica with the north-facing windows. And here I stumbled upon this tiny earthship home. I guess I like tiny. And so when I saw that somebody had built this tiny earthship home, 560 square feet, and I read that they spent under $10,000, I thought, oh, that's very impressive. Nestled into the earth. Here's the glass, here's the shading. Existing homes, we could talk all day on those, or buying and renovating. How about an accidental passive solar home, which is what I call a lot of them. I'll walk through a neighborhood and say, oh, look, there's one. So here's one I saw last week. And I thought it was really cool because here it is in winter, but the shade does not reach the south wall of the house. And this homeowner had all their blinds open, and they have the overhang line. You can see right up here at the top of the windows. That's probably 7% of the floor areas, and that the south glass is probably 7% of the floor area. And then here's some missed opportunities. Here's a house that, this is the west side. So this was the same time of day, the south facing wall. Here it is, this little bitty garage addition is the only wall getting sun. This house over here, they're getting some great morning sun through these windows, but then over here you look at the south side and there's no windows to be had, just the shade of a tree. We could spend a lot of time covering, passive solar and how it integrates into other rating tools, but we don't have time for that today. So Brett, maybe that's another subject for another conversation. Do you want to add anything about this, Brett?
Yeah, I think it's just important to know that for LEED and most green building programs now, they've delegated the passive solar to the energy modeling. So like, for example, in the HERS index rating, which they use, there are passive solar features that we talked about, all of them that we talked about here. So we've already talked about all these, Debbie, and they just take them and they just toss them into the energy model along with all the other things. And, as Orlo was telling me before the session, working with a good rater to put that information in appropriately, get you the information you need for LEED and other green buildings. So yeah, it's something we definitely talked about. So thanks for bringing it up.
Okay, so I promised some passive solar resources. If you have your phone with you and you want to screenshot this slide, that might be the best way, or you could go back and watch it. And Brett, you did say everyone got this PDF of the presentation.
Well, I mean, I never know who did or didn't, but we do try to
Okay.
get it out the door, and I can upload it here too for everybody as well if someone doesn't have it. So yeah.
Yeah. So anyway, you see a lot of links there, but the one at the bottom does not have a link. And this is actually probably my favorite one. If I had to tell you where to go, even more important than go look at my own website, would be search passive solar design strategies and put your state in. These are some PDF guidelines that I basically started my passive solar design career out of. They're based on extensive research that was done at NREL in the 80s. And it's really interesting how a lot of that information is still good today. You'll look at it and you might say, well, the wind to R value, you can now get one greater than, a R value of 2.5, or the U value, as somebody pointed out in one of the chats. We should be talking about the U value, which is the inverse. But anyway, those guidelines are still really valid, the basics of them. And the way they have it laid out, there's even worksheets that you could create your own Excel sheet and plug in all this information and figure out the percent of passive solar of your building. The top link, Christopher's tools, there's the link to his webinar that he did for Green Home Institute with the solar design tool. There's Orlo's with his holistically green living. There's 2 heat spring links that Mark Rosenbaum, he has his introduction to net zero energy buildings. And then he has a link to his main course. So if you want to check those out, then my own website down there at the bottom. Passive solar resources in terms of books. Here's Ed Mazria. Last year, he received the Golden Globe Award from American Institute of Architects. He wrote this book, the Passive Solar Energy book, which is, been seen as the Bible, has a lot of theory in it. The Rules of Thumb, Passive Solar Design Strategies, that's the one I just mentioned on that last slide. If you Google, you'll see a PDF that comes up, for your state. You might have to pick, one of 3 cities in your state. You're not going to be able to get your exact state, but has really good guidelines. This is my own book, The Sun Inspired House. It's out of print. I don't sell the print version anymore because I didn't reprint, but I have the ebook now, and the ebook is continuously being added to, and now it has over 150 examples of Orlo's relatively new book, which is definitely holistic, which I can recommend just for a good overview, includes passive solar. The Pretty Good House book, I've always really enjoyed the Pretty Good House concept, so I recommend that. And then the newest book, how many people have their new copy? Do I show my new copy of The House Needs to Breathe by Allison Bales, which really addresses the whole comfort mechanical side of building science in homes, which cannot be ignored if we're going to live in a comfortable home. And that's it. Thank you for attending. Enjoy creating your happy, sunny, and comfortable homes. So I guess now if anybody's still left on the session, we can take questions, right, Brett?
Yeah, let's get into those questions. We're going to get to some of them. And before we do, just real quick as a reminder for those of you who missed some of this or want to re-watch it, or share it. Go to our YouTube channel, click subscribe. You'll get an instant update when it's available here over the next couple of days. For those of you watching this in the future, not right now on demand, head over to our Thinkific channel and you can take your quiz as well as on USGBC, get an 80% passing rate, and you'll receive your certificate. For those of you watching live, as long as you've been here for the full CEU approved hour time, you can check your spam at certs@gutenbergcerts.com. You had to have been appropriately logged into Zoom, and you can receive your certificate that way. And before we get into those questions, again, always a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our 250, I think we just hit 256 members as of now. And thank to all of them and our top tier sponsors, Mitsubishi, April Air, and many of our other sponsors who have products who are going to help you build healthier and more sustainable homes. So I'm going to ask a question to you first, Debbie, but then I'm going to ask it to Orlo as well and expand it a little bit for his context. And so, Debbie, the question to you is passive solar. Okay, and with anything, right? We ask people to build better. We ask them to build green. And most of the time, the first thing is, well, how much more is this going to cost me? And when's my return on investment, right? So, but, what does it cost to design and build passive solar more or per square foot? Or how do you answer a question like that?
Yeah, that's a great question, Brett. And I do answer it all the time. So basically, if you looked at those basic passive solar elements, especially when you're looking at the slab on grade, you're looking at elements that are already in a house. Every house has windows, every house has insulated walls, every house has overhangs, and it has some kind of thermal mass, even if that thermal mass is one layer of sheetrock. And the reason that you don't start addressing thermal mass until you get to 7% is because of the sheetrock and the furniture and all the other things that are in the house. So if you take the normal amount of windows that are in a house and you just rearrange them so that most of those windows are on the south side, and then you're right placing the windows on the east, north, and west, it shouldn't cost any more. You're not adding any windows. You're just taking the ones that are already there and rearranging them. So it shouldn't cost any more. So usually what I will tell people is look for instance, I'm involved with custom designs most of the time. Look for other custom designs that are going on in your neighborhood for a comparison, because these passive solar homes that we design should not cost any more than those. Ideally, you'd want to look at one that is also at least being rated for Energy Star, because that aspect, even though it shouldn't cost more, sometimes builder pricing might have it cost more. Does that answer the question?
Well, and yeah, and so I mean, I think one point you had mentioned like slab on grade, right? So that in theory can cut cost on material and time if you're getting rid of that basement. But what about these like, these different solar heat gain coefficients on the windows or adding in overhangs? I mean, how does that usually play into the cost?
Yeah, well, that's a great question too, because and I honestly, it's been a while since I have heard of this, but it used to be in certain climate zones, say 3, for instance, which still might have 4 months of heating. It might be really hard to get a window that had a higher solar heat gain coefficient because it might not meet the prescriptive code. So sometimes clients were paying more for that window, but now that doesn't seem to be the case. I mean, you're allowed to, in most of the software, average the solar heat gain coefficients. So the clients are not having to spend more on the windows. I mean, I'm not going to lie. I'm not going to say that the windows in some cases are not more than your average home. But I find, if anything, it's not because of the passive solar. It's because, oh, wow, that is a great view. And yep, it's too bad from an energy standpoint that it's on the north. But we're going to put in the best window we can and right size it. And I mean, I've even moved windows around during construction to capture a view. You don't want to add more, which you might right size it.
Yeah. And so maybe just some design aspect costs, I'd assume, if you're starting with a design without passive solar, right? I mean, could that potentially be one of the impacts?
I'm not sure I understand the question exactly.
Well-
Maybe I'm starting to get a little foggy in my brain, but I'll tell you another thing I tell people is that let me right size your house. Because if
Right.
I could right size your house and I can take that 2,000 square foot house down to 1,800 square feet, we've just cut out 10% of the size of the construction cost, which way exceeds my fee.
Yeah.
So we're going to look at it from that standpoint.
Fair enough. Fair enough.
I might,
So, well, Orlo, I want to kick this one to you, but I really want to focus on something that I felt like I didn't hear. You know, I drive around and I see all of these subdivisions being built, and yes, they're not doing all the energy efficiency stuff that you suggested. That's one thing, and we're trying. But then I want to go and ask them, hey, we want you to redesign your entire community around the sun and take advantage of it, rather than what I imagine is happening, from my understanding, when I see these homes, is they're trying their best to just keep the sun away, right? Like, that's how we see all these homes designed. They have all these south or west facing parts of their home. There's no windows, right? It's just like, keep the sun away from me. So how do you convince developers doing all these community homes to shift it around and build towards the sun? Does that add more cost? Or is it just, they just, don't want to do it because it's just one more thing to think about?
well, I touched on that, builders, and that is an incredible challenge, is to get builders to think differently, even to insulate better or whatever. Because with the appraisal system, if they make the house more energy efficient, usually it has to come out of their pocket because the appraisal will not cover it.
Mm-hmm.
So then you say, well, okay, maybe the builder says after the house is finished, I'll just put solar electric panels on the house, even though that house has square wheels. Well, it is directionally going the right way, but the real solution is to build the house better. Now, if they just were to insulate it properly and test it midterm, it would make an incredible difference. I believe in passive solar, but I also believe in good insulation, good air sealing, and then proper ventilation so people don't die in their own halitosis or their own whatever. It's got to be ventilated right. And that is well. Now, we've been building passive solar homes one way or another since 1972, more intensely since 1978. And we used to say, look, we know the houses cost more, but it's the right thing to do. And yes, some people did it, even though it was more expensive. Now I think we can say with a good conscience, with explanation, that the houses are competitive when you look at the economics, principal, interest, taxes, insurance, and energy, which most people pay monthly. And then you say, okay, it's more economical, but we have an appraisal system that we need to work on so that the builders will do it. And it's an education. You're in education and Green Home Institute. We're in the education of what we're doing here. And I'm semi-retired, but my goal is to try to influence builders and buyers and realtors, and to somehow see that a $200 savings in their monthly utility bill is a tax-free investment and a dividend they get every month, tax-free. And it appreciates over value, and they lock in on their utility rates. And if they charge their car, they don't have to pay these exorbitant gasoline prices.
Yeah.
Really, we just need to get it educated.
Well, and you mentioned the sales and the appraisal process, and a realtor here was kind of asking, how do you identify passive solar on the sell sheet? Have you seen multiple listing services with checkboxes so one could check off that there's passive solar? Or what have you seen out there? I know MLSs are hyper local, so it's hard to say one is like the other, but
Debbie and I talked about that earlier, and what can be done for appraisers. I'm a past board member. It was actually part of the founding of Energy Rated Homes of Arkansas, which became Energy Rated Homes of America, putting numbers on houses. Now, ResNet, Steve Baden, who's the executive director, and the ResNet board has set up a means of a database where they have, I think, 3 million homes in the database that have turned, that are sold, that have been rated. And so an appraiser or a realtor can go to that database and say, I have 7 homes in the local area, which would apply. And several of them had really good ratings. And now I have comparables that compare to what the house is I just got to appraise or to sell. So that is another, I think, another webinar is the whole process of valuing real estate.
Yeah. So I think what I hear you saying is that the passive solar features are featured within the whole energy model of the home, and we need to make sure that that gets evaluated in totality of a house. And I guess I wonder though, because sometimes there's, and Debbie, you talked a lot about, there's all these other these other benefits of passive solar that may not show up in the energy model itself. So Debbie, have you seen anything out there on the selling point from a passive solar? How do you communicate? How does a realtor communicate that?
Yeah, that's a great question. I mean, I'd like to think that, say, for instance, clients of mine that have been repeat, they'll come back for a sun-inspired house number 2. They might say, we put it on the market and it sold really quickly.
Mm-hmm.
And you don't know why. I mean, it could be the low energy bills. It could be the excess or the right placed windows that adds light to, a lot of the spaces. I have heard another design professional, and I'm embarrassed, I can't think of his name, who was also a developer. He had it down to a science, could tell you how much quicker the homes that were, like Orla said, it's hard to break out the low energy and the passive solar, but the combination of something that's energy efficient and light and bright and feels really good, where you still feel connected to the outdoors. It's just hard to put a price on it, but he would notice patterns that, those houses were selling faster.
Mm-hmm. Yeah,
But
yeah, that
I'd
makes a
love
lot
to
of
see
sense.
some quantitative information on that.
Sure, yeah. So getting into some technical questions, I guess, I was looking at, someone was asking about how you get that passive solar that's, that heated area distributed throughout the home. Have you seen it, especially if they're larger homes? I know you said built right size, smaller, but if they're larger homes and could it overheat one area and underheat another? Could you use some sort of mechanical air system to move that heat around? Like, what are your thoughts on that?
Okay, do you want me to answer that, or you want to talk to that, Orlo? Well, I can mention it since I showed the one slide that had the little fan. Yeah, so I like that.
I'll comment on afterwards.
Yeah, more from a vertical standpoint, I like using the little inline fans, but also some of the energy recover ventilators can be run in recirculation mode.
Right.
So apparently they don't all have a recirculation mode, which I didn't realize, but
right.
That if you run those in recirculation mode, and talking to one of the manufacturers of an ERV, he said that they can do that. You can place it in the middle of the home. They can add a little bit of extra ductwork and associate it that way. I have had some mechanical designers that I've worked with that would look at each room, because a good HVAC designer is going to look at the load of each room individually. They're going to know that those south-facing rooms have on average a different load, and they may put some of the jump ducts in a wall that would allow the air to transfer, but not necessarily visual looking through a wall. Louvered doors, the same louvered doors that you might put in a mechanical room to allow the heat pump to get the warm air. Use louvered doors when you can in those cold rooms. But I think better is just address the spaces up front. If a client really doesn't want a hot kitchen because they cook all the time, then place it in a cold part of the home.
Anything else on that, Orlo? Or
Yes, I think going back to what is natural, hot air is lighter than cold air. It wants to rise. A cold air wants to settle. But if we stop the leaks in the house, particularly in the ceiling and up above where it flows out, then it can't flow cold or hot air, depending on the season, in. The whole challenge of circulating, because heat will move to the colder temperatures. And some of it just naturally happens with minimum air movement. And we have put a very small return air into 2-story houses, or even once in a high ceiling 1-story house, and just have a return air with one of the little blowers like Debbie was showing in the one slide, and just pull some air down from up above. And it's moving air when you have the house sealed is a whole different story.
a question here about what was it? What was the question here? It's really about code and how this passive solar is dealt with code. I'm assuming there probably really isn't any code violations per se, but with all the energy efficiency benefits that come along with this, have you seen codes being able to recognize passive solar, assuming that you might have a trade-off with something else, right? You know what I mean? Have you seen anything like that, or any barriers with the code officials?
Yes.
Oh, sorry.
Go ahead.
Well, okay. I was just going to say ResCheck, which is a tool that I'm sure most of the designers and builders are familiar with, that shows code compliance. It's not really a modeling tool, but ResCheck has webinars now where they are asking for input to individuals on how can they change and improve ResCheck. So I've sat in on those sessions and advising, let's add to the, because ResCheck is really a simple tool that a lot of people use. Let's try to add a layer where we can show the passive solar compliance, or not a compliance, but let's show the passive solar amount. It's beyond code. It's not required, but people that are incorporating it want to see it. And what I'm finding by interacting with this group of code officials and other professionals that know a lot more than I do about the codes is that a lot of jurisdictions are adopting stretch codes, and stretch codes are starting to recognize passive solar and passive cooling and all kind of other benefits. And it's always kind of amazed me that the code will say you have to have X amount of square footage of window in every room. You have to have X for natural light. So they're addressing that. They say there has to be a number of operable windows for both egress code and for natural ventilation, assuming the power goes out, but that they don't recognize that passive solar could help in a cold climate, and they require you to have a mechanical system. But they don't allow for an exception of not. I mean, without energy professional writing an exception. So sorry, Orlo, I probably spoke too long.
No. One of my prejudices is, and I think you were humbled, dramatically humbled to say that they know more than you do, because I think you know more than most building inspectors. And that's the truth about it. But building inspectors know how to read and then enforce the codes, but they don't know much about houses and house design and passive solar and mechanical systems and trends in society and all that. So we're continuously talking to building inspectors about, well, this is a mini split. And by the way, we don't get the same amount of air into every room and returning with the same, this whole thing about every room has to be heated and cooled equally with same pressure or whatever. We just essentially say, look, this house is different. And we've been around long enough, so I guess we have enough clout to say, look, trust us, we're going to make the customer happy. But it's a never-ending challenge. And I think they are evolving. Like you were just saying, I think they're evolving into more understanding of passive solar and energy efficiency. And but there's still some good old boys that are out there enforcing the codes.
Yeah. Well, Debbie, Orla, we are coming up on our time, but I really appreciate you all sticking around to hang out a little bit longer. We do have some more questions and we will send those over to you. And if you want to send them out to the group and answer some of the ones we didn't get to, and people can, I think, contact you all to ask questions. So maybe Orla, I'll just start with you. Where can people go to contact you or learn more about what you're working on?
Well, send it to my email. You have it at orlos@holisticallygreenliving.com. Send it there and I will answer them as best I can. Go to our website, go to our social media apps and maybe between what you ask and answer and what you find out for yourself through the different websites and social media, we'll get your questions answered.
All right. And Debbie, where can people go to learn more about you and reach out to you?
The website is sunplans.com and my email is debbie@sunplans.com. Can everybody see this last slide that I'm still sharing?
Well, they should be able to, but you just never know. So I appreciate you.
Okay.
It, so.
Yeah.
And it sounds like you're asking people to show off, right? And you'll be happy to promote them, right? In some of your presentations.
Yeah, I just love seeing what other passive solar professionals are doing. And some of the slides that I showed were people that I've met. I like it if it's somebody I've actually met in person, but then I find some other cool examples where I haven't, and I'm continuously building upon on this presentation. So it's just nice to find out who else is doing that. If other people have their own passive solar house plans, talk to me. I think there's a point where we need to be sharing information and resources. So thanks again, Brent, for asking me to present this session on passive solar.
Yeah. It was really great to see you out there virtually again, Debbie. I appreciate your time and your support of us. And Orla, it was good to virtually meet you, and I appreciate your time. And thank you all for joining us. This was our last session for the year 2022. So I think it was a really great way to end the year. I hope you all have a wonderful holiday season, and we will kick it right back off again in January 4th with our friends over at Pretty Good House. So I'm excited to have them on and do a book giveaway with them as well. So take care, everyone. Have a good holiday. Be well, be safe, and thank you so much. Bye.
Okay.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.